How to measure air quality and why you really should. Making devices to make a difference. That sounds good, doesn't it? That should be. I should be doing. Imagine a world. But I'm not doing so. That's okay. My name's Rob Miles. I'm doing a little screencast based on the lecture I gave at Black Marble a few days ago. I have the slides. I have a spangly new microphone. Can you hear my dulcet tones? And so I thought I'd do this. And besides, there's not on the TV. So yeah, robmiles.com is where I live. And let's have a look at what we're going to be talking about, shall we? Let's do just that. So why make... This is the overview. I could read it to you, but you can read. Don't forget the spider eggs at the end, because they're kind of exciting. At least I think they are. I have low standards with these things. Spider eggs. Spider. Yes, you don't. Yes, it's all good. So yeah, that's what we're doing. A bit about air quality, but mostly about the life-changing joy of making stuff. Okay, I spent a while at the university, the obligatory plug slides. I spent a long time at the University of Hull teaching programming and loved it. And then thought I'd try and do something else. So here I am doing something else. I'm a Microsoft MVP. I blog at robmiles.com. I tweet at robmiles. I write books. Here's 2 of my books. Begin to Code with C# with 1 5-star customer review. Thanks so much, Mum. That's lovely. I've also done Begin to Code with Python. I got the whole family involved. And they were quite appreciative. So I've got 6 reviews and 4.5 stars. But I can live with it. Anyway, I can live with that. That's all good. And if you want it by Sunday the 6th of May, order it quickly and you'll be fine. That's the plugs out of the way. Go to csharpcourse.com for my free book, which is the C# Yellow Book, which is world famous in my world. So those are the things to go for. Let's have a look at some nitty. Why make an air quality sensor? Indeed, why would you want to do that? Well, if you open the newspaper and go beyond the horrible headlines of whatever crisis is befalling your government of stupidity, you'll find some narrative about air quality, and there's quite a few people saying it's bad and getting worse. And yes, it probably is. I guess newspapers have to fill pages with something. But yes, there is an issue here, and we could do to know more about it. And this is one of these things where actually, as a person, as an ordinary bloke or lady or whatever, you can get involved and do stuff about this, and you can use tech to do this, and you can build your brand. And so it's all really good. You should be doing this. You should be working on these kinds of things. The news is full of stories about air pollution, and they say it's an ongoing health crisis in some parts of the world. It's known that small particles of dust in polluted air can move from lungs into the bloodstream, and that's a bad thing. We don't know the long-term effects. As I said at the talk on whenever it was, the human race has an annoying habit of doing experiments on itself just to see what happens. Let's burn fossil fuels for a long period of time and see what that does to the planet. The answer is nothing good. And the same is true with bad air, in that we're all driving around in cars, and I drive around in a car like everybody else, and we're producing these chemicals, and we don't really know what'll happen long term, our kids kind of thing. We just keep on doing these things because, hey, we're the human race. This is what we do. And I don't want people to lie awake at night worrying about bad air, because it's not something, it is there, and we should be aware of it, and we should attack these risks before they come and get us. But in the UK, I think things are generally okay. I think we're not one of the worst places in the world, which is nice, but not a thing you should be smug about. You should actually get involved and try and improve things everywhere, and that's really what I'm keen to do with technology. Now, DEFRA, the Department for the Environment, Food and Rural Affairs, actually about that, the Archers, I don't know, has some very good guidance on its website. There's some very good discussion of what's good, what's going on, and there's some good advice. And this is their official advice. They've got a paragraph on the effects of air pollution on health, followed by bullet points that bring out information for specific members of society, which is great. And you should take a look at that if you're concerned. And you can also get air quality indications about particular areas of the country. And you also find that if things are going to get bad, these things will appear on the news and weather forecasts and things. So yeah, we are aware of this, and people are doing things, but we can always do more, and we can always basically make more information and get more people focused on helping to try and find out what's happening, and then maybe even try and fix it. So it's all, we should still do stuff, because if you look at how they measure it across the country, they haven't got thousands and thousands of sensors. They haven't got lots and lots of things measuring quality all over the country. What they have is a few sensors and a large program and a huge pile of data. And what they do is basically they take in a bunch of data about where they know pollutants are coming from, and they know where cars are concentrated and all that kind of stuff, and they know how the rain and the weather affects the removal processes getting rid of the pollution. And they run this program on a continuous basis, and they then interpolate the numbers the program produces to get a feeling of what air quality is like at any given point in the country. And that's fine, but the key word on this slide for me is the word there, simulate. They don't really know. They might know the quality for a particular area over a particular time, but they don't know how bad the air is at the end of my drive. They don't know how bad it is outside a particular school gate, because we just don't have sensors in that position. We don't have any way of knowing. And so everything is calculated. Everything is worked out and then set out, which is, if you're in the government's position, it's probably the best way to do it. But we thought, oh, well, maybe since we're into local activity, maybe we can try and improve things. Maybe we can put some bits and pieces out there to try and find out if we can use cheap, low-cost sensors that we can use to help improve this set of data. Maybe we can lay our numbers on top of their numbers and see how they compare. Maybe we could get hold of their numbers and add our numbers to their equations and even make things even better. And this has turned out to be very interesting. And it's not all a technical problem. It's not all just about getting a sensor and making it work. There are all kinds of other issues that appear on the way, and those are interesting too. So what we're doing is very interesting. And if you're a young person looking to get into tech, looking to do things to build their brand and sort of improve their sort of knowledge and abilities, then getting involved in this kind of project is a really good idea. You can get hold of the hardware really cheaply. For the price of a AAA video game, for your price of Red Dead Redemption 2, an awesome game by the way, really, really good, you can get all the sensors we're talking about and the hardware to make them talk to the network and push values up. They're based on a thing called the Arduino, which is a standard. There are Arduino devices, but there are also devices not made by Arduino that work the same way, and they can customize this environment for lots of different devices. So you write the program once and run it across lots and lots of different platforms, and these guys are very cheap to buy, and they can be updated over the Wi-Fi if you want. You can put new programs in them without plugging them into anything, and they just work, and they're kind of fun, and they're good things. You can make robots, you can do all kinds of good things. So playing with the Arduino, good thing to do. And as I'm saying, this is a big thrust of my talk, if you like, is that if you want to learn how to do something, one of the best ways is to try and build a thing. We're going to learn how to sort of use a computer. Try and use it to solve a problem. Just learning stuff by watching videos and reading books is fine and might help you pass exams, I have no idea. But building something means that you get your hands properly dirty and you find out what the real problems are. We thought the hard part of our project would be getting the sensors to work with the computers and getting the data around the place. That's a challenge, but it's a thing that we've just done. Once we did that, stuff's got really interesting. It's a bit like a rabbit hole. You drop down the hole and all kinds of different avenues open up. There are all kinds of areas you can go off in. And this is great fun. And every time you do this, and every time you blog about it or publish a thing on a forum or whatever, or put things on GitHub or whatever. It's building you up as a person who knows about stuff. And going forward, looking for university places or places to work, this is the kind of thing they really want to hear about what you've been doing. And so you should do this. It's a great way to build yourself. And this is very important too. It's also an agent of change. I believe that you can use tech to change the way that people behave. If you make people better informed of the consequences of what they're doing, you can change what they do. I can remember, not that long ago, walking out and about in parks and on country lanes and whatnot was horrible. It was a minefield. There was poo everywhere. There was. Awful stuff. And the reason was that people were not managing their dogs. They were just letting their dogs go off and do things. Nowadays, that hardly ever happens. You can be a lot happier going out. And we used to use thousands and thousands of plastic bags. But now I carry a reusable one with me all the time, and I use that. People will change what they do if you inform them of the consequences of their action and give them a way forward. If we put some devices outside school gates and we find that on a quiet day, when the wind's not moving around very much and the air kind of concentrates and pools a bit, that you get massive accumulations of fossil fuel dust and whatnot because folk are driving to that school all the time, maybe we'll start to persuade people not to do that. Maybe we'll start having people arriving on bicycles or walking buses or whatever they do, walking trains or whatever they go. And maybe we'll do that. So you can, by giving people data and making them feel involved in the process, you can actually change the way they do things for the better. So think about that too. Really good. So let's get back to brass tacks. Let's measure some air quality. So how do we do this? Well, we thought we'd start with one particular indicator of air quality, which is the size of particles of a radius less than 2.5 microns. That's a not particularly magic number, because around that size, you breathe these things in, they stay in you forever, okay? That's the kind of thing. These things, they don't get breathed out, they get breathed in and stay there. And this is around a 25th of the width of a human hair, and it's smaller than pollen. And we can buy sensors, and this is the amazing part, that detect these particles and give us an output that tells us how many of these particles per cubic meter there are in air. So we can actually, you can buy things that claim to measure this. And so we can whistle off to Chinese suppliers or whatever, and you can buy stuff. If you look at the actual measures of air quality values and what the numbers from the sensors mean, here we go. The 2.5 microgram 2.5 micron radius particles. This is great, isn't it? It sounds wonderful. Micrograms per meter cubed. Okay, if you're going from 0 to 15 or so, that's fine. If you're going from 15 upwards, that's a bit moderate. If you're going above 40, then that's unhealthy. And when you get above 60 micrograms of 2.5 micron particles in a cubic meter of air, all on one breath, awesome, then you're heading towards uncomfortable territory. So that's the kind of thing which you should be looking for in your sensors. Professional sensors, the ones they have by the road, run by the council, also measure nitrogen oxide and ozone. But we can't really afford to. We've tried those sensors. They're very expensive and don't give us results that we can do much with. So we thought we'd try the cheap ones and go for looking at dust. So how do you measure dust in the air? Well, if you've been in a room which is lit by a shaft of sunlight and you whack a cushion so a cloud of dust goes up in the air, you will see the dust particles flickering in the sunlight. It's quite a pretty effect. That's how these sensors work. I have a LED shining a beam of focused light in this direction. I have a detector looking through a lens at this beam of light. Of course, it won't see anything because the beam's going straight down there, but if I have some gas in here that contains particles, they will scatter the light and they'll cause readings to appear on this photodiode. The resistor at the bottom heats the air goes in and rises up, and when it does that, any particles will cause this signal to flicker, and then we can read that. We have the whole thing in a tin box because we've got some very sensitive amplifiers underneath this diode that will pick up those signals. And so the circuitry around the back of this board here is looking for fluctuations in the signal the diode sees that indicate a particle of dust has gone past. And the idea is that it can measure particular sizes of fluctuations to get a feel for particular sizes of particles. And this thing, in all its glory, £5. So you can buy one of these and start measuring air quality for a fiver, which is awesome. As this is basically how it works. Yeah, laser sees the particles, and we basically get a number out which tells us what the particle thinks it's in. This has been scaled by the computer on the back of the sensor. So we get a number that's in the range 0 to whatever, where we know that 60 is rather bad and 100 is very bad. You go on online and you can find this is the same sensor packaged up with the lid on. There's the covering, there's the detector, there's the diode. Air goes in there, air comes out there. £2.83 to buy, £3.97 postage, which is £6. If you go to other suppliers, you can get them cheaper than that, and sometimes even post-free. But even so, astonishingly low price for an astonishingly complicated, advanced, and sort of precision device. Very, very impressed by the fact you can do that in the thing. So we get this guy and we make a sensor. This is my first sensor. There's my air quality reading device. This has a fan on it, so I can actually, it sucks air down this entry here. I can put a tube on here, so I can read from a distance. I can put a 1 meter tube on there and have my sensor indoors and my readings coming in from outdoors, which is great. My device has a nice little screen on, so I can see what it's doing. It also has a real-time clock there, and we discovered that the way that these particles work, if they get wet, they kind of attach themselves to moisture droplets, and that makes them a bit bigger. So you have to know the humidity when you get the readings, because otherwise the readings on their own don't mean a great deal. So this thing here, this little chip here, measures humidity, temperature and pressure, and that costs about £3. It's just, whoa, why is this so cheap? Anyway, that's nice. And then at the bottom I have a GPS receiver so that my detector can say where it is. This is the guy on the breadboard, prototype number. This is version 0. This is version 1 in a pretty box with a flower printed on the top, a display in there, and some buttons you can use to tell it what to do. And so, yeah, we've got all this stuff, and we're kind of in business, and now we're getting numbers. My little Heltec microcontroller, this cost me £12. You plug it into your computer, put a program in there, and you can make it do stuff, which is rather nice. Or you can buy this chap, which is a Wemos device, it's called, and that has Wi-Fi but no display, and I use it with coloured pixels, and these are £2.50. which is amazing. This is device number 2, and here displays a ring of coloured lights. Which indicate the air quality, and it uses a thing called MQTT, which is a way of pushing back the values. I don't want to focus too much on the tech in this talk. I've got some other talks coming down the tracks about LoRa and MQTT, which I'm sure you'll all rush out and watch. Yes, you should. You should do that. And when you do, you'll know more about those. This is just basically an overview of the field and why you should get involved, I guess. Everything I've got talks Wi-Fi, so I can just plug it into my home network at home and then away we go. But if I'm measuring the temperature and pressure and air quality from a place that has no network, then I'm in trouble. But a new tech called LoRa has just arrived, which solves that problem for me. This is low-powered, long-range radio. And the idea is I can use LoRa to push my values up to 2 or 3 miles from sensor to device and power the whole thing off a couple of AA batteries, which is rather sweet. It uses a technology which is called spread spectrum, which you don't have to know much about if you don't want to. That's fine. Just buy the device and use it. Think of it as a kind of SMS message, text message, rather than a phone call, because you can't send huge amounts of data. Then again, you don't want to for air quality. I can send my readings every hour or so. Things don't happen that quickly, and if they're not out of range, I could send nothing. I could sort of send even less. So the idea is that there's limits on the message size and how much you can use it, but that's all fine. We can still make that work. You can go quite a long way. There's different wave bands in Europe, America, and Asia, which is fine. No license required. Just buy the device and use it to talk to something. And yeah, it kind of works. It's rather nice. I don't want to make this too techy. There's a slide there you can read. This is the Semtech SX1276, which is the thing you should probably think about. This is made by a company called Semtech, and it does the LoRa thing for a device. So you buy it for a $5, connect your Arduino to it, and then hey presto, you're sending LoRa messages. Or you buy a device like the Heltec that has one of these things built in, and you're in business. The thing I'm saying here is that getting started is easy, cheap, and eminently doable. You can use it to link 2 devices together, so I could just use LoRa like an intercom, where I've got 2 people different ends of the channel one says hello, other one says, what did you say? And then you go on for a while being humorous or whatever. And you could do that. You could build your own protocol. But the thing I'm keen on is the LoRaWAN, because on this, you have a wide area network. You take your sensors, information gets pushed into the LoRaWAN, and it all just works, and the back end sorts it out. Now, I've got presentations on how LoRa works. You can go and have a look at those if you want to, and why would you not? So we're going to assume that LoRa is there and take a look at what it does for us, okay? And to do that, we go to the Things Network, which is one of these communities which is just there to do good. It's free to use. And once you attach yourself to the Things Network along with your physical devices, you can start using them to push data from a node into the cloud. And the idea is that you have these things called gateways that provide the connection to the cloud, and your device will talk to them, and you can get values. And they just provide the service, and it works worldwide. So if you go, well, in terms of the frequencies, if you go to Europe, your system will keep working. Your LoRa devices will still talk. You can buy devices. You can do things with them. This is the idea is you have these physical gateways, these bits of hardware that receive LoRa messages. You spread them around the place, plug them into the network backbone, and then you get LoRa coverage. I'd like a few more near my house, although my friend Robin down the road has got a LoRa gateway, so I can use that because it works. And the idea is that a LoRa gateway will work for anybody in the area using LoRa to do stuff, but a few more wouldn't hurt. I'd be quite happy with that. Let's have a look at some LoRa data. Now, in my bedroom, I have got a sensor which is quite happily chugging along and making sense of data. And let's go have a look, and here we go. This is my application. It's called my air quality sensor test, which is fine. And I have two devices attached to it at the moment because it's just a test one. And if I go and have a look in here, I can pick a device AQ01 and have a look at what he's doing. This is his address on the network. He was last seen 22 seconds ago, and these are the keys that I would use in that device to allow it to connect to my application. If I go and look at the data, here you can see what it's doing. It's sending every minute or so degrees Celsius, humidity, millibars, and then my two pollution values, 2.5 micron particles and 10 micron particles. So my bedroom is a fairly healthy place dust-wise, which is nice. And this thing will just keep on sending these values. It actually sends these 5 bytes, and I've encoded these numbers into those bytes in a way that the Things Network knows about and can then unpack. So I've got numbers that are coming into my system, and this basically shows me the values that are coming from my sensor. So I can do that. I can look at my LoRa data and I can push them out there. What we found as soon as we got this, we thought, great, we've made a sensor, we've got it going, we're in business. The answer is we're not, because now we have a whole bunch of other problems to solve. So you make something work and you now have other problems to solve. How do you manage your sensors? Making one is easy. Making lots is mechanical. You can make lots, but managing them, if I've got 500 sensors and 500 people and 500 addresses and 500 configuration things, this is hard work. This is product development. It's not kind of where we came in, but it's where we have to go. So we've built a protocol that lets you send commands to your sensors to tell them what their address on the network is and how often to send readings and all that kind of good stuff. And this is really proper. If I'm making, I could be an engineer making stuff, and I like writing software, but when it comes to making a thing that other folk can use, I have to worry about how the customer configures the Wi-Fi. What happens if something goes wrong? Have I got any security issues? If people start stealing my data or putting rogue values up there? How does the customer learn how to use my device? I have to solve all these problems too. And these are not programming. These are other stuff. These are lots of other skill sets come into play at this point. So a group of people working on this kind of thing is really useful. And so make a team of people to do things and have a go at them. And so the other thing is that once I've got my numbers, how do I know that my Chinese sensor, which is reading values and numbers are coming out of, how do I know they're sensible? Well, the answer is you buy a bunch of sensors and you plug them all together and you see if all the numbers that come out are the same. And if they are, then there's a good chance that at least you're getting a consensus. They're sort of repeatable. Then you, and we have actually had people in our Gadget Homebrew group do this, then you put them in smoke. and you see all the numbers change in the same way. You give them some numbers. This is experimental, but it's not like an experiment you do in a physics lab just to prove a theory. We're trying to find out if a £6 sensor you can buy from China is as good as a £10,000 sensor that the local government area is using to measure the same thing. And we're trying to get ourselves into what I would call a happy place, where we can say these things are reliable and repeatable and comparable with the grown-up ones. And it's proving great fun. We're trying to design things, and yeah, this is proper stuff. This is generating results that we hope will enable us to actually take our values and do things with them. And yeah, we've done the humidity thing. We're trying to find a place. We've actually been working with the council, so we can probably co-locate some of our sensors with their sensors and then compare the results and see how they look. This is all, yes, incredibly interesting stuff. Anyone can do this. It's not expensive. You don't need any qualifications. It's interesting. It builds your skills up. Really important point. It builds your brand up. Your brand is the thing which will carry you through life. It will get you jobs. It will get you interesting work. It will basically build, sort of get you through. And starting, well, young folk these days have to be brand savvy. You have to be working on the basis that I'm going to do these things and I'm going to make sure that I get the maximum possible benefit from doing them. And one of those benefits is having a brand. If you start doing things, put them on GitHub, make them available, write a blog about them, do some YouTube videos, get yourself out there. So when you go into a situation, someone says, okay, well, Rob, what have you been doing? Why should I hire you? Why should you study with me? What's your story? Well, I can say, well, I've made these things. Some of them work, some of them don't. The reason why they don't work is blah, blah, blah. That's the kind of stuff which people in those positions looking for folk to hire or get into college with or whatever, they want to hear you tell those stories. So make the stories, do the stuff. Great fun. And yeah, finally we get to spider eggs. There's always spider eggs at the end of everything. Maybe there aren't. I have no idea. This is a nice story which tells you what happens when you start playing with data. This is some data gathered by a friend of mine called Robin, who lives in a house just near me, or just down the road. And he bought 2 of the sensors from China, and he wired them up and made them work, and he got some numbers like these, and he was very unhappy because this guy here is giving readings that seem to make quite reasonable. They're going up and down, which is nice. This guy here is doing nothing. Why? Well, when that happens, you assume it's the software. So you try and fix your program. When you find the software's okay, you assume it's the hardware. So you look at your sensors. And after a while of doing just that, Robin discovered that a spider had crawled into the pipe to his sensor and laid some eggs and blocked the pipe. So this sensor here is getting no air. So no wonder it's reading very low values. This is the point at which Robin took the spider egg out of the pipe and bam, we're kind of in business. But the numbers are kind of diverging a little bit. At this point, Robin took the sensor which is one side of the fence and put it the same side of the fence as the other sensor. And now I've got 2 numbers that track themselves pretty well. So at this point, we've decided that, yep, these sensors are actually doing good stuff and they are working. And then we noticed that towards the end of this particular day, the air quality started to go downhill. And by these peaks, by the way, are when it's not that good. And interestingly, this one's around school time, dropping people off for school, which is not, or going to work, and there's a road outside Robin's house. And this stuff here is bonfire night, November the 5th, where everyone goes into their garden, sets fire to things and whatnot. And so we're kind of happy that the numbers that come out do reflect air quality at some level. We've got more questions. How long will it keep doing that? If I measure the same thing repeatedly, what will happen when it's windy? What happens to the numbers? Well, they do all kinds of weird stuff. And so we've got more and more questions to deal with, but we're going somewhere. We're doing things with this, which is rather nice. If you want to do this kind of thing, all the code that I'm making is on my GitHub repository, which is, I thought calling myself Crazy Rob Miles would be kind of cool and down with the kids, because the word Rob Miles had been taken when I joined GitHub. So I call myself Crazy, which actually just makes me sound a bit sad and wacky, whatever. But it's all up there on the air quality share. So go and have a look. I've even got the physical designs for the cases on there if you take a look at. If you're in Hull, You're very lucky because Hull is awesome. And you can come along to our meetings on the 1st and 3rd of each month at connectinghammer.org, and you can join us with our community at this address as well. We get together as a bunch of us. We're building sensors. We're playing with them. We also do things like mess around with robots, coloured pixels, learn how to use our Arduinos, all kinds of good stuff. Great place to come along and fiddle around with tech. So we are there. I'd love to see you. I'd love it even more if you actually start getting some sensors and doing some stuff. Please let me know if you do that. That would be completely awesome. And thank you so much for staying to the very, very end, even if it was just for the spider eggs.